the estimation we call the inferential statistic. Now we are moving on to now call the correlations. Okay, now this is going topic of your research paper if you are going to write one, and this is going to be the key that you need to understand. Okay, so the correlation, listen up. The correlation is a relationship between two variables here. So, for example, like I said, number of hours that you are using smartphone, and the GPA, or your height against your mom's height. And those are the correlations we're talking about, two variables only, right? So the correlation exists between two variables when one of them is related to in some way. Okay? And what we're going to do now is that we are going to quantify that relationship using what we call linear correlation coefficients. Okay? But the assumption here is that the sample of a pair data is random sample. Okay? And it has come from the normal distribution populations. Okay? Now, in order to find out, see if there's any correlation between two variables, we have to understand, or we have to at least find the linear correlation coefficient R. Okay? And this is a formula that you're going to find it.
Wow.
I'm not kidding. But we are not going to use this. We are using this guy here. And it's going to do that for us. Okay? So we are not doing this by hand. Okay? So now, the key thing here is this. The linear correlation coefficient measures the strength of a linear relationship. What do I mean by linear relationship? Huh? What do I mean by linear relationship? Line. It has to be a line. If it's not line, then you cannot use this. We have something other than linear coefficient for non-linear. This must be linear coefficients. Okay? And we're going to find their linear coefficients, and it's going to tell us whether there's the relationship or not between these two variables here. Okay? So we are going to look at the statistic to find the linear coefficient, but once we find them, okay, we have to understand what that means. So linear coefficient is going to be between 1 and the negative 1. Okay? So if the linear coefficient that we found is close to the 1, we are assuming that there's a strong correlation between these two variables. On the other hand, if we have coefficient that's very close to negative 1, it also has very strong relationship. Okay? So 1 and negative 1 indicates that we have very strong correlations between the two variables here. Now, on the other hand, if the coefficient is very close to 0, then it's telling us that, assuming that there's no correlation there. Okay? So we need to understand that. Now the problem here is this. What if it's going to be right at the 0.5? How do you know that? Do we have a correlation or do we don't have a correlation? So when we find the coefficient here, we are assuming that there's a correlation and there's no correlations. So in order to make sure that we have correlation or no correlations, we have to go through something called hypothesis test, just like you guys did last couple of weeks, right? So then, once you find the linear coefficients using StatDisk, we will have to go through the formal hypothesis test. Okay? But here's the properties of a linear coefficient. As I mentioned, your coefficient must be between -1 and 1. As you get close to 1, as you get close to negative 1, strong correlations. As the R gets close to 0, weak correlation, maybe no correlation at all. Okay? The value of R, the coefficient doesn't change if all values of either variable are converted to the different scale. For example, let's say we found the correlation between American dollars and the manufacturing goods, and we want to convert that in American dollar to the French francs or European, euro. It's not going to make any difference, okay? Because we are converting everything with the same scale there. Now, the linear coefficient is not affected by the choice of x or y. What that means here is that x can come first or y can come first. It doesn't make any difference. Okay? So when you type it in the stat disk, you can type x, y, or y, x. It's not going to make any difference when you find the linear coefficients. Okay? Again, the R measures the strength of linear relationship only. Okay? Not anymore. I mean, not all the other things. Okay? You got to remember this. This is going to be on the test, on the final. Okay? It measures the linear relationship only. Okay? So now, once you find the linear coefficients, now we have to understand whether we have the correlation or not. By just looking at the R that we found using StatDisk, sometimes it doesn't tell you. Just like 0.5 or 0.51, something like that. So we have to go through the formal hypothesis. So that means null hypothesis saying that this is a row called the row equals to 0, meaning that no correlations. No linear correlations. Now the alternative hypothesis is going to be that rho is not equal to 0, meaning there are linear correlations. Now, if we fail to reject, okay, it's telling you that no correlations. If we reject null hypothesis, it's telling us that you have correlations. Okay? So it's simple as that. Okay? Now, we also need to do is this. Okay? You can also use the test statistic here, T. Okay? Now the problem here is that we are not going to use the test statistic here. We're just going to find out what the linear coefficient is, and we're going to compare to the what we call the Pearson coefficients. Now that's going to be in your insert. I want everyone to pull out your insert. I'll show you exactly what that is. Okay? So once you find the linear coefficient, we are going to compare that. If you look at the table A5, and we're going to look at the table A5, okay? It will tell you the two columns of significance level. Alpha equals to 0.05, and alpha is going to be equal to 0.01. So that would be the what we call the Pearson coefficient. So once you find your coefficient using StatDisk, we're going to compare that to the Pearson. If your coefficient is greater than Pearson of these two columns, whichever it is, then you're going to reject the null hypothesis, meaning that you are rejecting this guy here, meaning that there is a significant correlation. Okay? So that's going to be a two-step process. Find the linear coefficient using StatDisk, and once you find that, you have to go through the formal hypothesis test. Set this up like this, then tell me your coefficient R here. Now remember, your R has to be absolute value. Okay? It's always going to be positive when you bring it out. And then compare that with the Pearson coefficient. Okay? And if your coefficient is greater than Pearson, you reject the null hypothesis here, meaning that there is a significant correlation. Okay? Reject null hypothesis, therefore significant correlations. Okay, so when you write the research paper, this is going to be a part of that requirement. You will have to go through the formal hypothesis test. You have to find out, see if there's any correlations there. Okay, so we are going to do this, okay, using the stat disk. Okay, so everyone bring up stat disk. Everybody install the stat disk? Or you can just watch mine, then when you guys do the thing. This is the new one. Okay. I have old one, which is not nicer than this. Okay. Okay. Now I'm going to try to show you here. All right.
I don't even know if I'm in the right place.
Okay.
Does that look right?
Yes.
So I just went to
Okay.
statdis.com and it
You can-
and it
let's
says
look at
open.
the,
And you open it. You have to create an account.
Where are we? Huh? Oh, here you go. Software, stat disk. I'm gonna run it. Why is it PDF file? Oh, they're telling me to go here. Okay, I'll do that. So let's just go to statdisk.org. Should go into the.
I went to open stat.
Go ahead, turn it off. Turn it.